cooking this time. Yeah, I think you'll find this kind of funny. So a buddy of mine sent this to me a couple of days ago. I don't know where this church is, but apparently I'm giving a, but what's interesting about it, so Apple in Scripture. So I said, well, what would I talk about? You know, maybe like how God doesn't want you to rush to upgrade to iOS 10 or something like that. You know, avoid the temptation, don't worship false idols, that kind of stuff. Any of you get iOS 10 yet?
I was one of the people that downloaded it right away.
Yeah.
And it broke my phone, so I had to restore it later.
Well, I got it later in that day. So far, I haven't been overly. I feel it's worse. Has been my opinion so far. It seems, and I mean, I have last year's phone, and it seems kind of sluggish, and then all the notification stuff just seems to be annoying. Like usually when I ignore a notification, I want it to be a one-time. I ignored it, go away.
And I don't like that they took like the today and the weather stuff out of like the swipe down. Now it's like the swipe over.
Oh, yeah. I guess I haven't messed with all the stuff yet, but yeah. Plus, it broke a bunch of apps. So several of the apps that I've written that do push notification stuff, because they have a new push notification system, all those broke because they're not using the new fancy schmancy push notification, dealy flippy majig stuff. Okay, so let's open up Eclipse here. So what we did at the end of class last time is we added a couple of Legos to our toolbox, specifically the Legos for reading stuff in from the user, right? All right, so for the homework assignments, the book had you do this little warm-up exercise. There's two problems we're solving, and they're kind of the same problem, where we just, we enter a little bit different logic in for what do we display, right? We're going to start off by doing our right triangle thing. So we're going to have us enter in a character and then the height of the triangle, a number of things down. So if we're going to have a triangle of height 5, we would print 1, whatever the character was, followed by 2, followed by 3, followed by 4, all the way down to 5. Okay? So let's go ahead and do that, and just as our warm-up here in class. So we proved that we were able to read 2 things in there. Now, the height of the triangle is this guy's coming in as a number of ints. Or this is coming in as a number of rows as an integer, rather. And we've shown that we can do that. So let's just start off by using that value to display whatever the first value they entered into the screen that many times. Simple little loop. All right, so I am going to do something rows number of times. What kind of loop lends itself to that? So I use a for loop, a while loop, a do while loop. For loop, why? What kind of problems do for loops lend themselves to? Counting problems, or problems where we know how many times we're going to loop through. How many times are we going to loop through here? Rows number of times. Good. Okay, so syntax for a for loop, and again, as a reminder, try to minimize the number of things that you cut and paste, or paste in there. Give yourself the practice of actually typing the stuff. So say for int I is equal to 0, I is less than rows, I plus plus. So this is our little shell of a for loop that will start a counter off at 0. We'll go up to, but not including rows. So if rows is 5, this will go 0, 1, 2, 3, 4, 5 times. All right, and each time through we'll add 1 to I. This is the same thing as saying I is equal to I plus 1. It's also the same thing as saying I plus equals 1. All right, so this loop is going to take I on a voyage between 0 and rows minus 1. Now, what I do each time through there is now up to me. Okay, so I'm repeating whatever I have in this block structure, in this case, 5 times if rows held the value 5. All right, so for right now, I'm going to go ahead and just print out whatever is stored inside of my character named C here, which is the char that we're going to print out there. I think what the book had you do, they had you call this char C, and they had you do char at 0. something like that for getting that individual character. It's fine. Either way is fine. This would crash, though, if you typed in more than a single character. It would die on you. So just to show you that, if I run this guy real quick, enter a character, and I do LOL as my character, oh, I guess it's not going to crash. It's going to give me the L. So I guess that won't be a problem. All right, so let's just go ahead and we're going to print out whatever this character is, rows number of times. So what's my Lego for printing stuff to the screen? If I say print something to the screen, what tool do you use? System.out guy. So system.out.println, and the character I'm printing out lives in what variable? That's its type. Its char is the type is char. What's the name of the variable? C. All right, so I wanted to print out whatever's inside the variable C. At runtime, this variable will resolve to the value that lives within it. Okay, so we see it as the variable C because we're writing this code to be generic. We don't know what value this guy is going to hold until the program's already running, because the user is going to provide that value. All right, so we're just saying, hey, print out whatever that variable holds when we get here. Okay, and we'll go ahead and do that. We'll do 5 times, and there's our 5 guys like that. All right, so now we're doing something 5 times. So we've got the height of our triangle right. But what we want to have here is we want to have a situation where its first row is 1 time, then it should be 2 of these, then it should be 3 of these, so on and so forth, right? So the first time through, I'm doing this 1 times. The second time, I'm doing this 2 times. Then I'm doing this 3 times. Then I'm doing this 4 times, so on and so forth. So what kind of thing do I need to have inside of this for loop? Another loop. Loops are for repetition, right? So I'm repeating something rows number of times, and each time through I'm going to repeat something some number of times, right? All right. So a couple different ways we could have pulled this off. First of all, each time through the loop, how many times do I need to display the current character on the screen? So I'm sitting right here and I'm asking the question, how many times do I need to show C in a row? Again, we're writing this generically. So we're solving a little puzzle here. How many times do I need to show C in a row? Well, the very first time through the loop, how many times am I going to show whatever's in C? 1 time. Second time through the loop, 2 times. All right. Now, do I have a variable in the loop that kind of tells me which time through the loop I'm dealing with? What's that variable called? I. So the first time through the loop, what's the value of I? 0. And how many times do I want to show the character C? 1. So how do I get a 1 from a 0? Add 1 to it. All right, so we'll have another little loop here. Well, here, let's just do this. We'll take it little baby steps. So we'll do system.out.println show C I plus 1 times. Okay, so the first time through, I plus 1 is 1, then it's 2, then it's 3, then it's 4. All right, so this is just going to give us some verbiage printed to the screen that tells us what we intend to do. Okay, proving that the value is, that we're kind of working with the right value. Go ahead and run this. We'll do that. We'll do that. So show C 1 time. Woo, woo, woo. Very funny. One times, 2 times, 3 times, 4 times, 5 times. All right, so since we ran into the bug there, what happened here when I didn't put the parentheses around this? Show you the output here again. We had a funky output. Just as a debugging exercise. It was 0, 1, 1, 1, 2, 1, 3, 1, 4, 1. So this is the value of I, right? 0, 1, 2, 3, 4. And then we're always putting a 1 after it. What's actually happening there instead of math? Go ahead. Yeah, it's concatenating them. It's gluing them together. And the reason for that is what's happening is we're taking this string, we're gluing onto it I. Then we're gluing onto that a 1. So we weren't actually doing the math with the I and the 1. So in order to force this guy to happen first, just like in a normal math class or something, you put the stuff inside of parentheses and that forces it to happen ahead of time. Okay. So there's our 1, 2, 3, 4, 5 times. So now that we've said what we want to do, we need to actually do it. So how do we repeat something some number of times? We use a loop. Now, some things we need to be careful of here is you don't want to have your inner loop operate on the same variable as your outer loop, because then they'll start conflicting with each other. And Java will be happy to scream at you. So if I come in here and I say for int I is equal to 0, I is less than I plus 1, I plus plus, okay, Java's starting to flip out on me here. If I highlight over the I here, it's saying duplicate local variable, rename it to something else. Okay, so I'm going to go ahead and change this to J. Keep going as long as J is less than I plus 1. So in this case, that version of I is correct. So we want to loop through some number of times relative to the current value of I. And then J plus plus. All right, and what do we want to do in here? We want to print something to the screen, but all on the same line. So we can either do this by building up a string and then printing the entire string, or we can do this by printing using just the print version instead of println. So we can say system.out.print C, and then after that loop is done, so after we've done it 1 time or 2 times or 3 times, whatever it is, then we'll do a system.out.println. And you can actually just leave it as println like that, or you can print out like the empty string. And that'll kick it down the line, like press enter at the end of the line. Okay, so we're going to do something rows number of times. What are we going to do each time? We're going to loop through 0 to I plus 1 and print out on the same line the current value of C, then kick it down a line, and then go back up and do that all again for the next row of our right triangle, so on and so forth. So run this. So there's our triangle. That makes sense? All right. Similarly, we could have built up a string rather than just doing it as prints here. So we could have done something like string temp string is equal to the empty string. So just have a variable to hold a string inside of that we're going to build up. And then inside here, rather than printing, we would say, so maybe right before this, we would reset temp string. It's equal to the empty string. Then we would say temp string is equal to whatever temp string is currently equal to concatenated with a C, the variable or the value that lives within the variable named C. And then ultimately we would print out temp string like this. Same output. So rather than printing the character some number of times, I concatenated the character onto a string, building that string, and then printed that string once. All right, so 2 solutions, same output. What else could we do? Well, we can do this. We can get rid of our inner loop entirely. We can say temp string is equal to temp string concatenated with C. So just add one more C on there and then print that guy out. So initially, first time through, temp string is nothing. Then it has a single character C on it. Print that out. Next time through it has 2 character C's on it. So we're building up that string each time through the loop. Run this. There's that, same output. So what's important for us to recognize here, and we can probably come up with a couple other weird ways of pulling this off, is we just wrote 3 separate solutions that all came out to the same output, even though we did it 3 different ways. Now, which of those ways do you think is the best? And there isn't a right answer to this. What's our opinion and why? Is this way the shortest? Yeah, this one's the shortest. Does that mean it's the best? How many of you solved it this way? Okay, 1.5 people solved it this way. All right. Yeah, I mean, that's the perfect answer. I mean, I think a couple classes ago, didn't I use the example of how do you peel a banana or something like that? Did I use that example in here?
No, peanut butter and jelly.
Oh, peanut butter and jelly. That's right. You had the made up way of the peanut butter and jelly, right? But yeah, well, but peeling a banana is a good one too. So when humans typically peel a banana, what do? They take the stem thing at the top and they pull that down, and that's how we do it. Have you ever watched a monkey peel a banana? They pinch the end of it, the other end, and they just pull it apart. It's like super convenient, super efficient. Start trying to do that. You start eating bananas like monkeys do. All right, but the point is, both of those, how many of you have never tried that? Try it sometime. You'll get into the bananas so much easier. And then you have the gorillas where they just bite it. What's a peel? We can keep going down the line. What does the shark do? The shark bites the human's arm off while it's holding the banana. And lots of different ways of getting the banana into your stomach. This is kind of the punchline. So, just like that, I mean, several of you are going to go and, hopefully several of you are going to go and try the new banana trick, right? How to open a banana. Do it at lunch today. The cafeteria usually has banana. What's up? Well, yeah, but that's more because of the heritage, and that's how you learn. What do you mean you'll mess up the banana? No, you don't pinch it in the middle. You pinch it on the end. The other end, you pinch it, and that like spreads it, and then you can just pull it apart. Yeah. Don't just start squeezing. Well, I guess that would probably work as well. Yeah. Eventually, one of the ends is gonna break. So So in any case, we have multiple ways we can make a peanut butter and jelly. Multiple ways we can eat a banana. Whatever it is, they ultimately all are getting the job done, right? So which way should you do it? You should do it the way that makes the most sense to you, not the way that's the least number of lines of code. I mean, from an efficiency perspective, this might be the one that's the best, but it also kind of breaks this logic of, oh, I need to repeat something. What tool do I use to repeat stuff? I use a loop. Well, we're missing that inner loop because we've kind of built that inner loop through just our logic of, oh, I just have to keep tacking on an extra character each time. Right? So we've effectively utilized our outer loop for both purposes, which is fine. So we came up with a interesting, efficient way of doing this, something along those lines. That doesn't mean it's better, and this will be one of the rare circumstances where he has a correct answer. You should do it. You should do it in the way that makes the most sense to you. Because this stuff has to be clear in your mind in order for you to solve the problem. This isn't a competition with the folks that are next to you. You know, you can look at their solution like, well, I don't even understand what that means. So, for instance, you don't have to raise your hand. I'm guessing there are several of you in here that are looking at this and still aren't sure exactly how that works. Just that it does work, right? Because it's like, well, that's weird. What the heck are you doing? Right? So you can break it down into little pieces, and we'll do that here in a second, just to kind of, fill those folks in. But this is kind of taking a shortcut, what we're doing here. We're using that outer loop for two purposes and kind of doing mathematical juggling, if you will. That doesn't mean that it's better. In fact, I would say for a beginning programmer, the better approach is, oh, I need to repeat something. That means I'm going to need a loop. And every single time you're going to repeat something new, you add a loop. So it becomes more by like paint by number. And then eventually when that becomes boring for you, when it seems easy, then you'll start being like, why do I just keep duct taping stuff onto the solution? And that's when you'll recognize that you're becoming a better programmer. All right, so if we kind of walk through this, I'll just create a little comment area down here. So we're going to have I starts off at 0, and we're going to have C, let's just do this. We'll do rows starts off at 5. We'll use our little example we've been creating. And then we'll have C is going to be the character percent symbol, which that's what we've been typing in. And then we have this variable that we created called temp string that starts off like that. All right, so these are the 4 variables that are at play here inside of our loop. Make sense? All right, so we read in the value for C, which was this guy. We read in the value for rows, which was this guy. Those are the examples we've been using. Then we created this loop. Well, no, then we created temp string. So this is how we create a variable. The type, followed by the variable name, followed by its initial value. So there's temp string's initial value, which is the empty string. Finally, we get to our loop. And in our loop, we initialize a variable. This part happens one time, where we create a variable named I, and we started off at 0. Now, for loops are pre-check loops. What does that mean? What does it mean for a for loop to be a pre-check loop? Okay, so we ask this question right here before we try to do any of the crap in here. That's what a pre-check loop means. We do it beforehand. A post-check loop, like a do-while loop, we would go ahead and just do this stuff once, and then we'd come back and ask the question. Make sense? So now we've just transitioned from saying it out loud to seeing in a practical example the difference. Pre-check loop, we are going to ask this question first. And only if that's true will we do this stuff. Specifically, only as long as that continues to be true will we continue to do this stuff. Okay? So is I less than rows? The current value of I is 0. Current value of rows is 5. Is 0 less than 5? You don't need a programming class to get that one right. Okay? Yeah, even you know the answer, right? Yeah, you got that one. Like first grade. Actually, do we know that? That's more like third grade stuff, isn't it? First grade, we were working at throwing food, I think. I did a lot of crayon eating in first grade, I think.
Did you have those sheets where you do 60 problems in a minute?
60 problems in a minute?
It started off like,
That sounds like new math stuff.
there was a sheet that was 6 by 10 grid.
Okay.
Simple stuff like adding 2 numbers. We would do 60 in a minute in first grade. And it was like adding, then second quarter was subtracting, third quarter was multiplication, fourth quarter was division.
That's in first grade?
Yeah.
I mean, I guess it's been a while, so I don't necessarily remember, but I mean, I think that, don't they have like the whole like new math thing now, like a different way of teaching math? I mean, I think when I was in first grade, I pretty much colored and ate crayons. I think that was first grade for me.
I was in the English program.
Really?
Yeah.
That's shocking to me, actually.
All the way until 5th grade.
Then things just went, as you got taller, things went downhill.
No Greek
As the blood flow, as I got taller, the blood flow wasn't going to the brain as efficiently. Yeah. I got paddled 3. They don't hit kids in school anymore, do they? Yeah. So I got paddled 3 times in first grade. Yeah, 1 time for eating crayons. Might have been twice for eating crayons. And then 1 time for we had like a spelling test, and we swapped papers for grading, and the girl who had like really nice handwriting, It was the word cat, and I changed one of the letters so I could mark it wrong, and I did not have nice handwriting. So yeah, the teacher was not fooled by this because the girl complained. So I got hit for that one too. And oh man, they take you down the hall. I remember it vividly. You go down there, they take you in this little closet with a single light bulb, and they had the weapon hanging on the wall. You know, like it was like with holes in it, like so that way there was no air resistance. Boom. They don't do that anymore, right? Stern talking to now, is that it? Yeah. See, I brought back the hitting students system a couple years ago. I can't do it myself because but if I get another student to throw a chair at a student, and then I just don't, I look the other way. I mean, kind of mission accomplished, right?
I'm good at throwing.
I've hired a shot putter. He does all my in-class beatings. All right, so pre-check loop, we ask the question first. All right, so we're going to ask, is 0 less than 5? Current value of I is 0, so this gets resolved. That gets resolved to its current value, which is 0. This guy gets resolved to its current value of 5. Is 0 less than 5? Yes, it is. That's a true statement. Therefore, we'll come in here. We're going to set temp string. So this is the assignment operator. The single equal sign is the assignment operator. So that guy assigns whatever's on the right-hand side to the variable on the left-hand side. So I'm going to assign into temp string. The new value of temp string will be the current value of temp string, which is currently the empty string, double quote, concatenated with the current value of C, which is the percent symbol. So empty string concatenated with the percent symbol produces that string. And I'll store that string back into temp string. Okay, so that's what I did right on this line here. So first time through, temp string is now equal to the string containing the single character, which is the percent symbol. Then I'll go ahead and print that guy out to the screen. So my output so far looks like that. Here, let me do a two-line comment here. So that's my current output. All right, and it kicked it down the line because I did this as a print len. Then I becomes 1 larger than it used to be, I++. So we go from a 0 to a 1. Then we ask the question, is the current value of I less than the current value of rows? Current value of I is 1, current value of rows is 5. Is 1 less than 5? Yep. We'll take temp string, we're going to set it equal to the current value of temp string, which is that guy right there, concatenated with another percent symbol. Then we'll print that out, kick it down a line, add 1 to I. Is 2 less than 5? Yep. Add another one, print it out, kick it down a line, add 1 to I. 3 less than 5? Yep. Add another one. Print it out. Kick it down a line. Increment I. Is 4 less than 5? Yep. Add another one. Print it out. Kick it down a line. Increment I. Is 5 less than 5? No. So we're done. We just failed this Boolean expression here. 5 is not less than 5. So we will not execute the body again. And we just fall right past it to here and continue on with our program if there was any more logic there. And there's the output of the program. Make sense? All right, so we kind of leveraged I here 2 different ways. We used I to take us through this loop rows number of times, we also used I to tell us how many C's we needed each time through. All right, so questions about that. So that was the first part of the homework assignment, right? One of those solutions or something along those lines. A bad solution would have been, well, I guess an incorrect, but a potentially meets most requirement solution would be for you to create a whole bunch of triangles. A triangle where rows is 1, a triangle where rows is 2, a triangle where rows is 3, and hard code those triangles in there. And then based on what the user entered, you ask the question, if they entered a 1, show this triangle. If they entered a 2, show this triangle. If they entered a 3, show this triangle. You have to have a lot of triangles until you run out of numbers, right? So enter a number of rows between 1 and 10. Then maybe it's more palatable that you only have to create 10 triangles. But this allows us to be, I guess, efficient with it. Nothing keeps us from running this guy, doing our, and me putting in, let's say, 30. It might not fit on the screen, but yeah, there we go, 30. Make sense? It looks like we actually could have fit way more than that. Maybe 50. Yeah. All right, so we've written a generic solution to a problem that gives us that we have the human being introduces variable data into it at the beginning. So if we chose a different symbol, I can enter the character the @ symbol and do 13, and there's a triangle made of @ symbols. Make sense? All right, so the second part of the assignment was to do a modification on this where we were creating what, like a half arrow, okay? So when we think about a half arrow, how does that make this more complex? What was a half arrow? A half arrow had like a consistent cadence of, what was it, 2 or 3 or something like that. And then it jutted out. And then kind of did a reverse triangle, right? Like pretty much what we did. So this is a normal triangle. So now we need to go backwards. So let's start off with just the backwards part. All right, so, and what was the inputs for the triangle? Was there any inputs for the half arrow? Was it number of rows?
Yeah, base height, base length, and then arrow head width.
Okay.
So had you taken 2 for the base, and then 1 for the head.
Okay, so base is how wide the base of the arrow is, and then base height is how long the total arrow is, and then the arrow width was, so that was like if it was 5, we would do like our upside down right triangle here. Is that the deal with it? So we brought in 3 pieces of information, 3 variables. So let's go ahead and capture those 3 variables, and then we'll build a little upside down triangle. Well, actually, before we do that, let's build our upside down triangle. Let's look at that guy. All right. So I'm already getting my inputs here. So I'm going to go from I is 0, I is less than rows. We're going to still have the same number of things. The height of our triangle will be the same. So I can decide to go from I is rows, I can do something like this, rows minus 1, keep going as long as I is greater than or equal to 0, and then do I minus minus. I can count down if that makes me feel better. But that loop will go through exactly the same number of times as the other loop would have gone through. We're just doing the math with I to make us go through by our example 5 times. All right, so we'll throw it back. So the purpose of this loop right here is just to do something 5 times, or do something rows number of times. All right, now once we are in here, we can't necessarily use that same shortcut anymore. because now we need to repeat stuff upside down. In a triangle of height 5, I need to do 5, then 4, then 3, then 2, then 1. Make sense? Now I could probably do something that removes elements from a string and rebuilds the string and stuff like that, but that's more difficult to do in Java. Strings are kind of one-way systems. Your book introduces some stuff to replace elements of a string and that kind of stuff. But strings are once we get something into a string, they're malleable, but we really can't take it away. We have to rebuild a new string. Okay? So now we're back to our kind of our go-to solution where we're going to look in our toolbox and say, how do I, inside this loop, how do I create 5 C's? How do I create 4 C's? How do I create 3 C's? That type of stuff. Okay? So we're going to go ahead and we're going to throw another loop in here. So we're going to say for int I, or int j, let's go. J is equal to 0. J is less than. It's probably benefit us to go backwards here just to keep this simpler. So we're going to start I off at rows. Keep going as long as I is greater than 0. Subtract 1 from I each time. So the first time through I will be 5, then it'll be 4, then it'll be 3, then it'll be 2, then it'll be 1. So I will represent, in this case, because of the way we've done the numbers up here, will always be exactly equal to the number of C's that we need in that line. Okay? So we're going to have J is equal to 0. Keep going as long as J is less than I. J plus plus. And then we can go ahead and build our temp string if we want to do it the temp string way. Or we can just do the print thing. So we'll do a system.out.print C. When we're done with this, we'll do a system.out.println, the empty string. So we're going to go through the height number of times, rows number of times. Each time through, we're going to start with the larger value. So we'll have C 5 times, then C 4 times, then C 3 times, because I is getting whittled down. It started off at 5. Second time through, it'll be 4. Then it'll be 3. Then it'll be 2. Then it'll be 1. There's our upside down triangle. That makes sense? Now, we could have played with the math here. So if you liked your original loop and you wanted to say I starts off at 0, keep going as long as I is less than rows, and add 1 to I each time. First time through, I is 0. We really need I to be 5. So this guy right here should be I plus rows. Well, it's not going to quite get it. That works the first time through. 0 plus 5 gets me 5. But the next time through, I need it to be 4. So when I is 2, when I is 1, I need to subtract 1 from it, right? So I would do rows minus I. 5 minus 0 is 5. 5 minus 1 is 4. 5 minus 2 is 3. So on and so forth. Same output, had to deal with the math a little bit differently. So understand that this loop goes through the identical number of times that it did the way we wrote it a few minutes ago. We're just counting with different numbers. We can go through things 5 times. We go between 10 and 15, or 0 and 5. Still going through the same number of times. We're just counting with different numbers. All right. So we've created our little puzzle here where we have numbers that start off like that, and then based on those numbers, we've written the correct code here. We've printed out some stuff here, and then we kicked it down a line. So that gives us our the end point of our arrow. Okay, and how tall is the arrow supposed to be? There's an arrow height in this question, right? What's that guy called?
So it's like it takes base height, base width, and then arrowhead width. So like.
Okay, and then does it hard code in the character?
Yeah.
Or it's still asking for the character?
It didn't say to ask for a character. So.
Okay, well we'll leave our character asking thing in because we already have that. All right, so then we want you want base height and base width.
Yep.
And then arrow height.
Yeah, like it says they called it arrowhead height.
Arrowhead height. AH height.
Or arrowhead width, sorry.
Oh, arrowhead width. Okay. So arrowhead width. Okay, so we just count down to 1. Got it. All right, so we'll go ahead and still let them enter in the character they want to build the half arrow from. And then we'll get the height of the everything up to, but not including the arrowhead. And then we're going to get the width of everything up to, but not including the arrowhead. So let's just get that part working. All right. And so we can practice. We'll go ahead and dump our loop here. Start from scratch. All right. So we want to go ahead and we're going to put a little comment in here and say, make the base first. So we want to do so many characters in a row, right? So many characters in a row. How many characters in a row? Width, number of characters in a row. Height, number of times. Make sense? Okay. So we're going to go ahead and we're going to, now we could approach this a couple different ways. Since we're basically creating a column of, let's say our width was 3. Our thing was the percent symbol. We're really creating a column of 3% symbols, 3% symbols, 3% symbols, 3% symbols over and over again, right? So we could generate the string that is 3% symbols once and then use that string over and over again. These don't have to be loops inside of loops if we don't want them to be. We can write one loop that builds our string and then have our next loop that prints it the correct number of times. All right, so let's do it that way. So make the base first. So let's initially, we'll just do a step 1 here. These are comments, the 2 slashes. So let's build the string that is our character with number wide, something like that. All right, so we have our string temp string, and actually I'll go ahead and just move that down here so we kind of put it with this logic. And then I'll say for int I is equal to 0, I is less than with I plus plus, and we'll say temp string is equal to temp string concatenated with C. Okay, so when we're done with that loop, temp string will hold C with number of times. We have a single string with C with number of times. Make sense? All right, so one thing I want us to start seeing here is patterns. Doesn't this look pretty similar to something we had already done? So we're actually solving a sub-problem there. Right? We're saying I want to make this string hold something. What something do you want to put in there? Well, I'm going to go ahead and build it for you right here. I want to hold in there this many of these guys. And I'm going to build it onto this variable. All right, so this is a little loop that builds up a string. So now I have my string. So now I want to display this to display the base. I want to display this string how many times? Height, number of times. So I is equal to 0, I is less than height I++, and I'll do system.out.println temp string. So I want to, after I built my temp string, I want to display my temp string height number of times. Now, is it okay that I use I right here? Well, if we go strictly by Eclipse not complaining about it, the answer must be yes. Why is it okay for me to have int I is equal to 0 here and then use that variable again right here? A few minutes ago, we purposely chose to use an I and then a J, right? Why is it okay for me to use two I's here? Okay. Why, being separate, why does that make it? Why does that make this different? I mean, you're right. It is because they're separate, but there's got to be a reason why having them separate has caused the making this okay. Go ahead.
Wasn't the other one an inner string or an inner loop to the?
I referred to it as an inner loop. It was a loop inside of another loop. So also related to the right answer. So I'll answer your question and say yes, it was. Why did that make a difference?
Because it was for that certain variable in the loop, right? So this next one here is closed it off. Started a new one.
Okay, so putting your two answers together, you're saying that this guy is kind of a self-contained animal, and this guy is kind of a self-contained animal, and they don't really impact each other. Once this guy you mentioned closed it off, once this guy ended, all of this stuff kind of went away. But didn't temp string still stay with us? Because we used temp string down here, didn't we? See, in his head right now, he's thinking, oh, I must be wrong, but no, you're not. We just haven't quite gotten to the core of the answer yet. How many of you remember from last semester when we talked about scope? Remember scope? Not the mouthwash. What's scope? When I say variable scope, what am I talking about? And I'll talk about it again here in a second because I see the deer in the headlights look. When I say variable scope, what am I talking about? No, not the right scope.
Isn't that like where the variable exists? Like it can be like a global variable and then it can be accessed anywhere by the program.
Okay, so what scope might mean to us is where can we access a variable. So then so based on that, we need to understand what differentiates scopes from each other. Okay, so let's draw this pretty much the same picture we drew last year, but let's attach it to our code here. So we'll see the difference. So we're going to have this thing that we're going to call the global scope. There's global scope. Okay, so our global scope for us right now, in fact, actually, just to really attach it to our program, we're going to have global scope, and then inside of global scope, that's good enough. Main scope. And then we're going to have for loop scope. And another for loop scope. All right, so going back to our program here, global scope is, we can typically see scopes when we look at curly braces. All right, There are probably some circumstances as curly braces aren't always required, as we've kind of discussed, where that's a partial lie. But if we all follow my rule and say always use curly braces, it's never wrong to use an opening and closing curly brace, we can identify scopes when we see curly braces. So we have a global scope here, that is everything that lives after this opening curly brace and before the corresponding closing curly brace. Everything in there is part of the global scope. And actually, once we start writing objects, there's even a bigger global scope. Roll with this for right now. All right, this is our global scope in terms of our world right now. Inside that, we have a more local scope. That is the scope that is defined by our main method. There's its opening curly brace, and there's its closing curly brace. Now, inside of that scope, we've defined a couple of variables. We've defined input, C, height, width, AH height, and temp string. So inside of our main scope here, we have input, C, height, width, AH height, and temp string. Those are all variables that belong to the main scope. All right. We have two loops here. Each of these loops have their own scope. All right. And they each have a variable associated with their scope. Each of them have a variable called I. So even though these guys look pretty similar, they are physically different I's. All right, so if you have two houses that are right next to each other, they're same neighborhood, so these houses were built off the same blueprint, right? Any of you live in one of those neighborhoods, or we know what I'm talking about, right? So some subdivision where all the houses are the same. And we have toilets in both houses. Same exact company, Kohler made the toilet or whatever. Okay, those are physically different toilets. Right? It would be weird if you walked into the bathroom and found something in your toilet that you didn't put there. Right? It came from the other house. And about halfway through that joke, it started going south. But you get what I'm saying, right? We can replace the toilets with TV sets. Okay, you start flipping channels on your TV set. Hopefully, the neighbor's TV set doesn't change. Those guys are separate from each other, right? All right, so this eye, even though it looks just like this eye, they are physically separate eyes. That make sense? Because they live in separate scopes. But inside of a scope, you have access to all of the variables that exist in the scopes in which you live. So this loop right here, because he lives inside of the main scope, he has access to the main scope's variables. He also has access to the global scope's variables. In this case, we have no global scope variables, but he would have access to it. He would not have access to any variables defined inside of this for loop, the second for loop scope, because those guys live separately from each other. Each of these guys have access to the scope in which they live, but this guy never lived inside of this scope. This guy never lived inside of this scope. They're separate from each other. Now, when we had the for loop on J inside of one of our loops, so when I created a loop inside of a loop, and I originally tried to put an I in there, now we have a conflict. This is a little bit earlier when we had a loop that had, we used J as our counter instead of I for this reason. This loop lives inside of the scope of this loop. This loop already has a variable named I. When I tried to redefine the variable named I, these guys got confused. Okay? Now, since we don't have an example to show it right now, I'll just mention that it's possible. This is not always illegal. For example, if I had a variable named I globally, I can define a more local version of I that would do what's called shadow it. Okay, it would. So every variable, if we were going to kind of give ourselves a rule of thumb, a variable always resolves to its most local definition. A variable always resolves to its most local definition. So if I have a variable I inside of main, well, let's say I have my variable C inside of main here. If there was another variable at the global level called C, my variable C in here, if I tried to use C inside the main scope, would resolve to the most local version of C, which is the one closest to it, which is the one defined by main, not the one at the global level. All right, that's allowed in some circumstances, and we'll talk about those. It's pretty clear when it's allowed and when it's not, but since we don't have an example sitting in front of us where we can look at it, I don't want to get too far into it. It is not with loops. Okay, specifically for loops. For loops are the loop out of our 3 loops that we know about. For loops are the loop that come with their own scope. While loops do not, do while loops do not. And part of that is because of the way for loops are kind of self-contained animals. A lot of the stuff that we need for counting kind of gets sucked up into the header of the for loop. So, you know, they're this self-contained thing, and as part of that means that they get their own, I wouldn't even call it a full scope, but it's a scope-like entity that comes with a for loop. When you guys take the programming language theory class 470, we actually write a programming language and we learn how you would implement a for loop in there and how it impacts your variable environment. But for us here, we'll just call it a scope. For all intents and purposes in our world, it's a scope. Okay? So when we had a loop inside of a loop, specifically a for loop inside of a for loop, I could not reuse this I. It was against the special rules that go with for loops. So I needed to use something like J or something like that in order to differentiate my counters. That make sense? All right. So again, just to continue to remind you of this stuff, I want you to, as we look through this stuff, take each of these things we're talking about and add it to your toolbox as one individual widget. We've already seen today that we've utilized the same little pattern of code, maybe the same little cadence of for loop in 3 different places, right? When I look at our code right here, this stuff that I did right here a little bit ago lived inside of a loop somewhere. Now I've pulled it out of that loop, but I'm still using it, and it still accomplishes the same thing it did before. But now I don't need to accomplish it each time through the loop. Now I really just need to build that width of my base once with this loop. Then I'll use that width over and over again. That makes sense? All right, so this is a pattern. This is my tool that teaches me how to define variables. This is my tool that teaches me how to write a loop. And this is our brain inserting some logic in there. This is the actual problem solving step. All right, this is where we actually need to activate our brains and think through the problem, is what goes inside of that loop in this case. The rest of the stuff is all just structural, get the hammer out, get the chainsaw out, and we can do a lot of stuff with those too. Not good stuff most of the time, but we can do things. All right, so we've built our temp string that is the width. Then we're going to go ahead and print it out to the screen height number of times. So we should get the base of our arrow here. So we'll look at so we're going to enter our character. We'll build our arrow out of percent symbols again. The base height, what do you want to do, like 10? Base height is 10. Base width is 3. Good enough. And then the arrowhead width, we're not using that yet, so we can just put whatever we want in there. Let's do 7. All right, so now what we should do is we should get something that's 10 high and 3 wide as a vertical bar, because that's what we've built here. Make sense? All right, and now we have our arrowhead width. And with our arrowhead width, what do we want to do? We want to build our upside down triangle. Isn't that the guy we want? All right, so we did that a few minutes ago. So we need our upside down triangle so we get the thing that comes out and goes down. So now, so this was step 2. Step 2 here was display the base height number of times with temp string that is width what? Something like that. And here I can do that. Okay, step 3. Now I want to display upside down triangle as the arrow head. Okay, and I know the height of this guy is AH height. That's equivalent to what we had earlier called rows. Remember that guy? So we used to call this guy rows. In fact, we could even call it rows again here if you want to call it that. So we're going to have our loop. So for int I is equal to 0, I is, actually let's start I off at rows. I is greater than 0, I minus minus, so subtract 1 from it each time. Now I want to display to the screen that width, right? All right, so first time through I want to display a width of I characters, so I'm going to need that inner loop to pull that off. All right, so, and again, this is a loop inside of a loop, so this inner loop lives inside of the scope of the outer loop. So I need to pick a different variable other than I. So we'll say for int j is equal to 0, j is less than I, j plus plus, and I want to print to the screen my character I times. All right, so we'll do system.out.print. Did I call it C still? Yeah, C. And then to kick it down a line, we'll do system.out.println, the empty string. So this will, if rows was 7, this will print out 7% symbols. Then 7 becomes 6, this will print out 6, so on and so forth. So we'll enter our character. There's our character. Height is 10. Width is 3. Whatever. Arrowhead width is 7. There's our guy. That solved the problem. So notice how he broke it down into the smaller pieces. All right, so now my suspicion would be, now how much does the book help you with this? Or did you have to do most of it in your own brain, right? Okay, so my suspicion is that maybe 10% of you found this homework not that bad. Okay, probably a majority of you felt this was pretty challenging, especially the second part. Okay, first part wasn't as bad because you only had 2 balls to juggle at once, right? With this guy, you have more things going on, and we have to train our brain to slow down and break it into these individual pieces. Okay, I'm going to get all the tools out of my toolbox first. Okay, so all the little, the right size screws, all the stuff I need, I'm going to lay out. So that's what we're doing up here. We're getting all the values we're going to need. Now I need to do stuff with those values. Okay, well, what do I do first? I'm going to do this stuff first. Then I'm going to do this. Then I'm going to do this. We're used to doing that in real life. We're used to breaking problems down into things like that in real life. But just like we've been talking about in class, as humans, we're intimidated by computers. We assume it must be different. We assume it must be difficult. And because of that, we have trouble continuing to do what we already do in real life. All right, so break things down into small baby steps and you'll have a lot more success with this stuff. That makes sense? What I'll do here, let me just grab this code. Let me go into Slack. Let's go to 250. And I'm going to add a snippet. Paste that in there. And we're going to do half arrow solution. Can I literally not get to the bottom part of the screen? Can I just hit enter? It's a well-written software there. All right, so now you guys have that in your the 250 thing. All right, so let's look at our book for a moment here and see where we're going next. Did I close? Oh, there it is. Like, did I close the book? All right, so that was at the end of loops. So we've completed the loops chapter now, right? Okay. So arrays, we're going to go through a little bit slower. So let me look at. Well, actually, we're not going to go through that slower. I think we're okay with that. So for your homework, let's read chapter 5. Let me look at this real quick. All right, let's read chapter 5 and just do the warm-up exercise. I think that's going to be complex enough for us. We'll look at the other one in class. All right, so homework, read all of chapter 5, and then do 5.12 for your assignment. Sound good? All right, I will see everybody on Tuesday.